Observability and SRE Part 17. This episode has 11 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Cross-namespace pod communication. Can pods in different Kubernetes namespaces communicate by default, and how would you restrict or allow it deliberately? Here's a strong way to approach it. Yes, by default Kubernetes networking is flat and any pod can reach any other pod's IP across namespaces, since namespaces are an API or RBAC boundary, not a network boundary. To restrict this you apply network policies, requires a CNI that enforces them, like Calico or GKE's dataplane v2, that default deny ingress in a namespace and then explicitly allow traffic from specific namespaces or labels via namespace selector and pod selector rules. To allow it deliberately across namespaces you typically expose a service and reference it via its cluster DNS name, service namespace SVC cluster local, and permit that specific selector in the policy. Nice. Let's continue. Question 2. Multi-stage CI or CD pipeline. Walk me through a multi-stage CI or CD pipeline you have built, stage by stage. Here's a strong way to approach it. A typical pipeline I've run: checkout and static analysis, lint, unit tests, SAST, fails fast before anything expensive runs. A build stage compiles or builds a container image and tags it with the commit SHA. A scan stage runs image vulnerability scanning and blocks on critical CVEs. The image is pushed to artifact registry. A deploy to staging stage applies manifests via Helm or Customize or Terraform, and runs integration or smoke tests against staging. And finally a gated production deploy stage, often manual approval plus canary or blue-green rollout, promotes the same immutable image or tag that was tested, with automated rollback wired to health checks or error rate slows. Great. Moving on. Question 3. Jenkins agent restriction. You have 5 Jenkins agents but only want a specific job to run on 2 of them. How would you configure that? Here's a strong way to approach it. Label the 2 target agents with a shared custom label, e.g., deploy prod, in each node's configuration. Then in the job or pipeline specify agent, label deploy prod declarative or node, deploy prod, scripted, so Jenkins scheduler only assigns that job to nodes carrying that label. For more control, like limiting concurrency across the 2, combine labels with the restrict where this project can be run field and throttle concurrent builds per label using the throttle concurrent builds plugin or a lockable resources block. Alright, next question. Question 4. Skip a Jenkins stage. A pipeline has stage 0 through stage 3. How would you configure it so stage 1 can be skipped on demand? Here's a strong way to approach it. In a declarative pipeline, wrap stage 1 in a when block driven by a parameter, e.g. a boolean build parameter skip stage 1, and write when expression return param skip stage 1 on that stage so it's conditionally skipped rather than removed from the file. Expose the parameter via parameters boolean param name skip stage 1 default value false, so it shows up as a checkbox on build with parameters, which lets whoever triggers the build decide at runtime whether stage 1 runs, while Jenkins still records it as skipped in the stage view rather than silently absent. Let's keep going. Question 5. GCP services experience. Which GCP services have you worked with hands-on, and in what capacity on each? Here's a strong way to approach it. This is a resume deep dive or behavioral question. Answer it as a specific, structured inventory rather than a list. For each service, name what you built or owned, e.g., GKE, administered multi-tenant clusters, node pool sizing, upgrades, RBAC, Terraform, wrote and maintained reusable modules for VPC or GKE or IAM across environments, cloud storage or BigQuery, built data pipelines with lifecycle policies and IAM least privilege, Cloud Composer, orchestrated ETL DAGs, Cloud Armor or Cloud NAT or load balancing, secured and exposed production services. Interviewers are listening for depth and ownership signals, so pick 4-5 services you can go deep on rather than a shallow list of everything you've touched. On to the next one. Question 6. GKE networking overview. Explain how networking works in GKE at a high level, from pod IP allocation to external traffic. Here's a strong way to approach it. Each GKE node gets a node IP from the VPC subnet, and each pod gets its own IP from a secondary IP range, alias IP range associated with that subnet, which is what makes GKE pods natively routable inside the VPC without overlay networking. In VPC native or alias IP clusters, the default and recommended mode, pod-to-pod traffic on the same node goes through the local CNI bridge or EBF data path. Pod-to-pod across nodes routes through the VPC using those alias IP ranges. Services get a stable cluster IP that kubeproxy, or dataplane v2 or EBF in newer clusters, load balances to backing pod IPs, and external traffic enters via a service of type load balancer or an ingress, which provisions a GCP L4 or L7 load balancer in front of the cluster. Good. Here's another one. Question 7. Pod-to-pod communication. How do pods communicate with each other inside the same GKE cluster? Here's a strong way to approach it. Every pod gets a real, routable IP from the cluster's pod CIDR, via VPC native alias IP ranges, so pods can talk directly pod IP to pod IP without NAT, the same as any two hosts on a flat network. In practice, most communication goes through a service, cluster IP, rather than raw pod IPs. Because pod IPs are ephemeral, the service provides a stable virtual IP and DNS name, and kubeproxy or the EBF dataplane v2, load balances requests across the current healthy backend pods, so callers never need to track individual pod IPs directly. Nice. Let's continue. Question 8. Cross-namespace GKE networking. In GKE specifically, how does cross-namespace pod communication work at the network layer? And how would a network policy change that? Here's a strong way to approach it. At the network layer, namespaces don't segment traffic at all. GKE's flat pod networking means any pod can route to any other pod's IP or service regardless of namespace. Exactly like same namespace traffic, GKE enforces network policy either through Calico, older dataplane, or natively through dataplane v2, EBF-based. And once you apply a default deny ingress network policy in a namespace, cross-namespace traffic is blocked unless you add an explicit allow rule using a namespace selector, matched by the target namespace's labels, combined with a pod selector, which is the standard way to permit only specific cross-namespace calls. Great. Moving on. Question 9. Exposing GKE externally. How would you expose a GKE application to the internet, and what options would you choose between? Here's a strong way to approach it. The main options are a service of type load balancer, provisions an external L4 network load balancer, simplest but no HTTP routing or TLS termination features, a GKE ingress, provisions a GCP external HTTP/S, application load balancer with host or path routing, managed TLS certs, and Cloud Armor integration, or the newer Gateway API, the more flexible, standardized replacement for ingress with better multi-team or multi-cluster routing support. For a production HTTP service, I'd default to ingress or Gateway API fronted by Cloud Armor and a Google-managed SSL certificate, reserving a bare load balancer service for non-HTTP protocols that don't need L7 routing. Alright, next question. Question 10. Securing external URL. Once an application is exposed externally, how do you secure that public endpoint end-to-end? Here's a strong way to approach it. Terminate TLS at the load balancer using a Google-managed certificate so traffic is encrypted in transit, and put Cloud Armor in front of it with rate limiting and WAF-style rules, SCLI or XSS pre-configured rules, geo-blocking, or bot protection as needed, to filter malicious traffic before it reaches the cluster. Behind that, apply identity-aware proxy or your own auth layer for anything not meant to be fully public. Restrict the backend service or ingress with network policies so only the load balancer's traffic reaches the pods. And keep logging or monitoring alerts wired up so you'd actually notice an attack in progress rather than just having controls that look good on paper. Let's keep going. Question 11. Cloud Armor purpose. What is the purpose of Cloud Armor, and what kinds of threats does it protect against? Here's a strong way to approach it. Cloud Armor is Google Cloud's WAF and DDoS protection service that sits in front of external HTTP/S load balancers and TCP or SSL proxy LBs. To filter traffic before it reaches your backends. It protects against volumetric and protocol DDoS attacks, leveraging Google's global network edge scrubbing, OWASP-style application attacks, SQL injection, XSS, remote code execution via pre-configured WAF rules, and lets you write custom rules to rate limit, allow or deny by IP or geography, or block based on request attributes, all enforced at Google's edge, before traffic ever reaches your GKE cluster or VMs. On to the next one. That wraps up this episode. Nice work practicing, and see you in the next one.